Hello, welcome to this screencast. I'm going to go through a couple of the questions on the paper. Question 3 was a speed time graph, speed on the vertical axis, time in seconds on the horizontal axis. And the first part asks you to calculate the distance travelled in the first 40 seconds, which is up until this point here. Lots of people got no marks for this question because they wrote distance equals speed times time equals 8 times 40, and they got the answer 320 meters. And I gave no marks for that because you completely misunderstood what the graph was telling you. In actual fact, the speed of this bus is increasing from 0 to 1 to 2 to 3. It's only going at 8 meters per second at the very end of 40 seconds. And so in actual fact, what you needed to do was to find the area under the graph, which is a half times 40 times 8, and that gives you 160 meters. You could have got 3 marks by writing distance equals average speed multiplied by time. But if you just divided by 2 and didn't explain what you were doing, you can see here we've written distance equals area under the graph, or if you'd written distance equals average speed times time, you'd have got all 3 marks. And then on the second part, lots of you didn't read the question carefully enough. It says the distance travelled between 40 and 80 seconds is 315 meters, between 40 and 80. So the area under this second part of the graph is actually 315 meters, which means that the total distance travelled is 160 meters between 0 and 40, another 315 meters between 40 and 80, giving a total of 475 meters divided by 80 seconds is 5.9 meters per second. I did give ECF here, so you could have got all 4 marks if you'd used 320 meters from part A and got therefore 635 meters, which gave an answer of 7.9, I think. So I did give ECF here. You could have got all the marks, but you didn't get all the marks if it wasn't clear what you were doing. There are 4 marks here: equation, sum, answer, unit. And so to get the marks, this was a pretty simple question. You had to explain very clearly what you were doing. And then the final part of this question, between 40 and 70, it's a constant velocity or a constant speed. And between 70 and 80, it's a constant deceleration. You can see here that in this work solution, we've given the value of the speed and the deceleration. You didn't need to do that to get the marks, although it was nice if you did it. But you can see here from the graph, constant speed and then decelerating. Okay, then we moved on to question 4, and the mark scheme was very specific here. You've got to be able to spell ammeter. No marks for ammeter, ammeter with 1 M, ammeter. The kind of thing that you might put on a barbecue with the meat in there. And then you had to understand that ammeters measure current. For this part, what flows in the circuit? Well, charge flows. It's a flow of electrons in an electric circuit. And then on this one, I was pretty tough on this. It's 2 marks. If you just rolled 24, you got 1 of them. If you wrote down 16 plus 8 to get 24 or something like that, you got both marks. And again, the mark scheme was specific. There are 2 marks. You've got to do 2 things. And you had to show how you got your answer to get both marks. I equals V over R. Actually, most people got this right. The odd person divided 24 by 12. Some people were led astray by other equations on the formula sheet, but most people were able to do I equals V over R here to get 0.5 amps. No marks for a lowercase a. It's got to be a capital A for amps. And be very careful. Some people wrote a C here. C for current equals V over R. I knocked a mark off if you did that. C is the letter we use for the units of charge, coulombs. You're expected to know that the letter I is used to represent current. Blame the French for that. Intensité is how current used to be talked about in the early days of electricity, but you are expected to know that I equals V over R. And then finally, the last part here, what is the potential difference across the 16 ohm resistor? Well, you know that V equals IR, and if the switch is open, I will be 0. So therefore, V will equal 0 multiplied by 16, and 0 times 16 is 0. So the answer was 0 volts for that question there. And that was the end of my part of the marking.